So look at the next question. So we need to show that the vector function has no divergence. So look at the given function here. Okay, it's a vector function. Let me call the coefficient of I as f1. Okay, so f1 as which is 3x minus 2y plus z, right? And let me call this f2 as 4x minus 5y minus z, and the coefficient of k as must be k, right? The coefficient of k as f3 equals to, which is x minus y plus 2z, right? Okay, so now we need to show that it has no divergence. That means we need to show that the divergence of f is 0. So what is the divergence of f here? So it is given, the divergence of f is given by, it's given by the dot product of grad and f. So this is nothing but what? It is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, right? Yes. So which is dou by dou x of, which is 3x minus 2y plus z plus dou by dou y of, what is f2, which is 4x minus 5y minus z plus dou by dou z of which is x minus y plus 2z, right? Okay, so now we need to calculate the partial differentiation, right? So here we need to differentiate partially with respect to x. So other than x, all are constant. So 3 is constant, the whole thing is constant, right? So the differentiation, so 3 is constant, the differentiation of x with respect to itself is 1 minus the differentiation of 2y plus z, which is constant, so it is 0, right? Plus, and here we have to differentiate with respect to y. So other than y, all are constant. So x is constant, here 5 is constant, and z is also constant. So the differentiation of constant for x is 0, minus 5 is constant, the differentiation of y with respect to itself is 1, minus the differentiation of constant is 0. Plus we have to differentiate with respect to z. So x and y are constant here, and 2 is also constant. So the differentiation of constant x minus y is 0, plus 2 is constant, the differentiation of z with respect to itself is 1. So it is 3 minus 5 plus 2, which is equal to 0. So we can conclude that the divergence of f is 0, and hence the vector function f has no divergence. Now look at the next question. See, we need to, in electrostatistics, the electric field, okay, is given by, so the function, the vector function f is given, and we need to show that the given electric field is irrotational. So we need to show that the curl of f is 0, and then we need to find the scalar potential. Okay, so first we need to write the let me consider this part as f1, and the coefficient of j as f2, and the coefficient of k as f3. Okay, let us calculate the partial differentiation of that. So it is f1 equal to, what is that, which is 6xy plus z cube, right? And what is f2? So f2 is which is 3x square minus z, and f3 is 3xz square minus y, right? So now we need to calculate the partial differentiation of this. So dou f1 by dou x, what is that? We have to differentiate this with respect to x, or simply we can first write the formula. Okay, so later we can do the differentiation directly. So what is the curl of f? So the curl of f is given by the determinant of, so I, j, k. Here it is dou by dou x, dou by dou y, and dou by dou z, and here it is f1, f2 and f3, right? So this is equal to, again, I into, delete the corresponding row and column, so write this, it is dou f3 by dou y minus dou f2 by dou z, right? So minus j into dou f3 by dou x minus dou f1 by dou z. Okay, so plus k into the partial differentiation. So we have to delete the corresponding column and row, which is dou f2 by dou x minus dou f1 by dou y, right? Yeah, so we know what is f1, f2, f3. Let us do the differentiation directly. Okay, so here we have to differentiate f3 partially with respect to y. So x and z are constant here. Okay, since we are doing differentiation with respect to y. So here 3xz square is constant, so it is 0, minus the differentiation of y with respect to itself is 1, minus, let us differentiate f2 with respect to z. So x and y are constant, so 3x square is constant, the differentiation of that is 0, minus the differentiation of z with respect to z is 1. Okay, so minus j into, let us differentiate f3 with respect to x. So y and z are constant, here 3z square is constant, so write that first, and the differentiation of x with respect to itself is 1, minus the differentiation of y with respect to x is 0. Okay, so minus, let us differentiate f1 with respect to z. So x and y are constant here, so 6xy is constant, the differentiation of that is 0, plus the differentiation of z cube is 3z square, plus k into the differentiation of f2 with respect to x is here 6x, 3 into 2x, that is 6x, minus 0, right? Y and z are constant there, minus the differentiation of f1 with respect to y. Here x and z are constant, so 6x is constant, so write that first, the differentiation of y with respect to itself is 1, plus the differentiation of z cube is 0. So we can say that, we can clearly see that minus 1 plus 1, which is 0, and 3z square minus 3z square, that is also 0, and here plus 6x minus 6, that is also 0. So the whole thing is 0. So we can conclude that the given vector function is irrotational. Now we have to find its scalar potential. Okay, so we have to find the scalar potential means, see, we have to find the given vector function is f. We have to find the scalar potential means we have to find phi, the scalar function phi, in such a way that the gradient of that is equal to the given vector. Okay, yeah. So what is f here, which is let us write this, let us substitute the values of f and phi. So what is f, which is 6xy plus z cube into I plus 3x square minus z into j plus 3xz square minus y into k, that is equal to gradient of phi. What is that? It is I into dou phi by dou x plus j into dou phi by dou y plus k into dou phi by dou z, right? Okay. Now we have to calculate the value of phi. So on equating, look at the coefficient of I. Here we have dou phi by dou x, here we have this. So on equating, we can say that dou phi by dou x is equal to 6xy plus z cube. We have this in one hand. And on equating the coefficient of j, so we have this dou phi by dou y, that is equal to 3x square minus z. On equating the coefficient of k, so we have dou phi by dou z, which is equal to 3xz square minus y, right? Okay. So let us calculate phi by direct integration. So let us integrate the first equation with respect to x. So while doing that, we have to consider y and z as constant. So the integration of dou phi by dou x is phi. So that is equal to the integration of 6xy plus z cube. We have to differentiate this with respect to x. And here y and z are what? They are constant. So what happens here? Here 6y is constant, take that outside. The integration of x is x square by 2. Plus z cube is constant, take that outside. The integration of 1 with respect to x is x. Plus we need to write the integrating constant. The integrating constant is what? It is some function of y and z. So let me call this as c of y and x, y and z, which is some function of y and z. Okay, let me call it as g. Okay, g1, let me call it as g1, right? Let me do the same thing for this. Let us do the direct integration with respect to y. So phi equals to the integration of 3x square minus z. With respect to y, we have to integrate here, and while doing that, x and z are constant here. So what happens here, which is 3x square is constant, the integration of 1 with respect to y is y, minus z is constant, the integration of 1 with respect to y is y. Plus we need to write the integrating constant. The integrating constant is what? Here x and z are constant, so it must be a function of x and z. Let it be g2 of x and z. And here we have let us do the direct integration with respect to z. So phi equals to integration of 3xz square minus y with respect to z. While doing that, x and y are constant here. So what happens here? It is 3x is constant. The integration of z square is z cube by 3 with respect to z, minus y is constant. The integration of 1 is with respect to z is z. Plus we need to write the integrating constant, that is g3 of x comma y. So on observing these three things, let us simplify this. What is this? Which is 2 1s are 2 3s are, which is 3x square y plus xz cube plus the integrating constant g1 of y comma z, the function of y and z. Here this phi is what? Which is also again 3x square y minus yz plus the function of x and z. So in this case, it is 3 get cancelled, which is xz cube minus yz plus g3 of x comma y. Right? So here we have this. So on observing these three values of phi, we can write the entire value of phi. So look at this question. So we have 3x square y. Right, here also we have 3x square y. Okay, so write that. And here we have xz cube, the function of x and z. And here also we have okay, let us write that x and z cube. Right, and we have a function of y and z here. No, that is a constant. So here look at this question. We have minus yz, so we can write that here, which is a function of z. And here also we have minus yz, and we have xz. Okay, so this is the required scalar potential.